Now that we understand the theory behind this substitution method, we're going to look at some substitution examples. Remember, when we're identifying the u, not only the u, but we also need to make sure the du is in the problem as a factor. So let's take a look at some examples. And as we do that, there's one little caveat that we need to be aware of, is we can make a minor adjustment on the constants by multiplying and dividing to maintain balance. Let's take a look at what that means with several examples here. Let's try taking the integral of 6x e to the 2x squared minus 7 dx. Now, one thing I notice is there's a 6 here. That 6 is a constant, can move out of the integral. So I'm going to do that. I'm going to move the 6 out of the integral. So all that's left inside the integral is the x e to the 2x squared minus 7. Now, we can't just take the antiderivative of that, because we don't know who has a derivative of x e to the 2x squared minus 7. But if I make u equal to that entire exponent, u is 2x squared minus 7, that would become e to the u power. We like e to the u power, and we can take the derivative of u as 4x dx. There's already a dx. There's already an x. We need a 4. And that's that constant we can adjust. I can multiply by a 4 inside the integral as long as I keep balanced by also dividing by 4 outside the integral. So let's look at what that's going to give us now. We've got an integral with 6/4 out front. 6/4 is going to reduce to 3/2. Then the 4x dx all becomes du. And the e's exponent now is a u. And this is an antiderivative we can take really fast. The antiderivative of e to the u is e to the u. And of course, we need a plus c. The only thing to fix then is that exponent of u. U is 2x squared minus 7. So we have 3/2 e to the u, which is 2x squared minus 7, plus a constant. We now have the antiderivative of our problem. Let's try another example. Let's try the integral of 3x minus 1 times 3x squared minus 2x plus 4, all to the 5th power dx. I don't know any derivative who gives me this big ugly thing as an answer. But what if all that stuff to the 5th power was my u? What if u was 3x squared minus 2x plus 4? Then it becomes u to the 5th power. And that's much easier to work with. Remember, my du needs to be in the problem as a factor. Du is going to be the derivative 6x minus 2 dx. Well, we don't have 6x minus 2. We have 3x minus 1. But notice what happens if I multiply that 3x minus 1 by 2. Distributing through would give me 6x minus 2. That's exactly what I need. But to stay balanced, if I multiplied by 2, I also have to divide by 2 on the outside. So now the 2 times 3x minus 1 and the dx are all going to be absorbed into the du. We have the 1/2 out front. The 2 times the 3x minus 1 dx all became du. The 3x squared minus 2x plus 4 all becomes a u. And it's to the 5th power. That gives me something I can easily integrate. Increase the exponent by 1 makes it a 6. Divide by a 6. 2 times 6 is 12 now in the denominator, plus a constant. But just like before, we don't want u in our final answer. We want the 3x squared minus 2x plus 4. So we have 1/12 times 3x squared minus 2x plus 4, all raised to the 6th power, plus a constant as my final antiderivative. Let's try one more example. Let's try to integrate x squared over the 5th root of 2x cubed minus 9 dx. Well, if I look at my denominator, if everything under this root was just one thing, we could write that as u to the 1/5 power. So let's make that our u. Let's make u equal to 2x cubed minus 9. Its derivative du then is 6x squared dx. Well, we only have x squared. We need a 6x squared. So we'll multiply by 6 and divide by 6 so that that 6x squared dx can all get absorbed into the du. We now have 1/6 times the integral. That 6x squared dx all became du. And we're left with 1 over the 5th root. All that stuff became u. Well, I know I can rewrite this as the integral of u to the negative 1/5 power du, so that I can increase the exponent by 1, which makes it 4/5, multiply by the new exponent, or multiply by the reciprocal, which is going to be 5/4. We still have the 1/6 out front, plus c. Let's go ahead and multiply that together. 1/6 times 5/4 is 5 over 24. And now all that's left is to replace u with what it represents. We have 5 over 24, u, which is 2x cubed minus 9 to the 4/5 power, plus c. Substitution problems take a little bit of practice to get used to, identifying the u and adjusting the constant by multiplying and dividing. But practice is the best way to get good at that. So it's your turn to try some of these. Practice identifying your u, du, and simplifying the problem to something we can integrate.